let's look at kind of a fun, sometimes not so practical way to use synthetic division, but it's definitely neat to look at. So we're going to look at evaluating a polynomial function. So we've turned a polynomial such as this into a function. So this is now the output of some function. Okay. So how do we evaluate a polynomial function? So for example, if I said determine, so this, I've given you the definition of the function f. If I tell you to determine f of 17, then what would you do? Well, you would take 17 as your input, and you would say, okay, I'd have 4 times 17 to the 6th minus 71 times 17 to the 5th plus da 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 da, and you would get some number at the end. Okay, very calculator heavy, and not, to be honest, much fun. So let's look at a fun, more interesting way to determine, for example, f of 17. All right. What the key is, we can use f of x has many different forms. So what we're going to do is come up with a different form using synthetic division that's going to make it easy to determine f of 17. So what form is this? Well, what I would like, I'd like f of x, this thing here, to be written as x minus 17 times, I don't care honestly, plus some remainder. Now look at this. Then, if I can write it like that, then f of 17 will equal, then I still plug 17 as my input. So I would have 17 minus 17 times, who cares, plus this remainder, right? And what happens is, oh yeah, this is 0, so when I multiply 0 by who cares what, this whole thing is 0. And all I end up with is 0 plus my remainder, which I can add that in my head, okay? So the question is, how do we turn f of x into this form? And the answer to that is synthetic division. If I want to write it like this, I better divide my function, my original function, by x minus 17. Okay? So that's what we're going to do. So let me clean this up a little bit. So we're going to rewrite this crazy polynomial f of x using synthetic division where we divide by x minus 17. Okay? So how do we set that up? Let's get rid of this so we have some more space. How do we set that up? Well, I've got to first start with the crazy f of x polynomial. So I've got 4 x to the 6th, negative 71 x to the 5th, plus 51 x to the 4th, plus 2x cubed, minus 35 x squared, plus 20x, plus 2, divided by x minus 17. The 0 for x minus 17 is positive 17. Sorry about that. So positive 17 is what's going to go here. Okay? And now I can go through my division to rewrite f of x. And then I will answer the question here. So I drop my 4. 17 times 4 is 68. Negative 71 plus 68 is negative 3. 17 times negative 3 is negative 51. 51 plus negative 51 is 0. 17 times 0 is 0. 2 plus 0 is 2. 17 times 2 is 34. Negative 35 plus 34 is negative 1. 17 times negative 1 is negative 17. 20 plus negative 17 is 3. 17 times 3 is 51, and 2 plus 51 is 53. Didn't use a calculator there. You may need to, depending on how good you are with arithmetic in your head. So what this means is, so f of x equals this stuff, okay? I don't want you to forget that. That is what f of x equals. But an alternate form would be, well, x minus 17, since that's what we divided by here, times the stuff on the bottom. That would be 4x to the 5th minus 3x to the 4th plus 0x cubed plus 2x squared minus 1x plus 3 plus my remainder of 53. So this is a different form of f of x. Now I'm going to answer the question. What's f of 17? Well, f of 17 is 17 minus 17 times, who cares, because when I multiply all this stuff together, I get, this all becomes 0 plus 53. 0 plus 53 is 53. So f of 17 is simply 53. And you should verify that just for your own understanding. If you were to plug 17 in to this form, using a calculator of course, you should also get 53. So just a fun sort of novel way to use synthetic division to actually evaluate a polynomial where you would never think that you would need synthetic division to evaluate a polynomial, right? You just plug it in. The key is this function has a lot of different forms, and we've learned that you can use synthetic division to create different forms of a polynomial.